Hello friends, welcome back to my YouTube channel MS Maths. In this video, I will explain some important functions and their graph, the domain range and the property of that function. This is the part 6 of real analysis basics and it is helpful for IIT JAM, GATE and CSIR-NET as well. My name is Manoj Solanki and I will start the video. Please like the video, share the video and subscribe the channel. Press the bell icon to get notified about the next videos. You can follow my YouTube channel for higher mathematics and higher education related videos. And this is all about real analysis topic. You can follow real analysis, all the parts from 1 to 6. You can access from my playlist, which is available on my MS channel, MS Maths YouTube channel. Now let's start the topic. So it is what, first of all, we will explain some categories of function, that is basically some elementary function. Then we'll discuss some different kind of function like trigonometric function. We also discuss some important function. Okay, and there are some types of rational and irrational kind of function, some piecewise continuous function. All the functions we'll see one by one. So this is called f of x is equals to x, and this is the function which is a straight line which is passing through the whole horizon. So something is that to understand or to identify that a function is passing through or a curve is passing through the horizon or not. So whenever you have any function f of x, for a function of one variable, that is f of x, then in that case, if you have something f of x and it is a function, and we are talking about only for function of one variable here only. So is it passing from origin or not? So just it should satisfy 0, 0. It means at x is equals to 0, the function value must be 0. Then we can say it is passing through the origin. What if it is passing through 1, 1, then it must be like that x is equals to 1 and f of x is equals to 1. Okay, so if you want to find out that this particular curve or function is passing through the particular coordinate or not, then that curve or function must satisfy that that particular coordinate, okay, that you want to, on which you want to identify that the curve is passing through or not. So for the simple case, it is what function f of x. So it is a line which is passing through the origin, and it is simplest case which is making 45 degree angle with x-axis. Okay, and this is what the simplest linear function is here. Okay, linear is why the power is 1 here, and it is passing through origin. Now what is the domain for this function? Domain means that, okay, for any function, domain means that from where we are taking the inputs. So it is what domain, it is taking all the values of real number. You will take any kind of real number, so it is taking from here to here. So domain for this is set of real number. This is nothing but set of reals. Okay, what is the range? Range is something which is taking as output, or the set of basically we can say that the set of element of codomain which has a pre-image in domain. So it will take all the real numbers. So it is same as set of reals is again the range of this function. Okay, so note is that we can make some comment on the function. First of all, this is a odd function. Okay, this is a odd function. Okay, this function is a odd function. Why it is odd function? So the definition of odd function that we have already discussed in function and their properties. Odd function means that a function minus of x is nothing but minus f of x, so it is called odd function. Or if a function f of x is equals to f of x or minus f of x is equals to f of x, then it is called even function. So it is a odd function if I will take minus of x, and it will give minus of x here. Okay, so this is odd function. Similarly, it is also symmetric function. Okay, symmetric function, it means it will take 2 at 2 here. Okay, similarly it will take 4 at 4 here, and the same thing is that opposite image is here. So if you will put x is equals to 4, you will get y is equal, like f of x is equals to also 4. And another thing is that it is a increasing function. Oh, okay, it is what? Increasing function. It will increase like this. It increase with the value of this. Okay, it is -4. If it is -4, okay, here it is -4. Then after that -2, it is greater than this. Okay, same thing is that 2 is greater than, 4 is greater than 2. Then function value will also increase here. So this is what increasing function. Okay, next we have f of x square. Now here, like f of x is equals to x square. This is a parabola. Okay, you have some function 4a of x square. Okay, this is a parabola, and whenever we are taking this like y is equals to ax square, okay, then whenever you have any function of x square and in which we have this power 2, then it is obviously it is what the quadratic function. It is a quadratic function here, and the domain which is taking, that is real number. It will take complete real number. It means from x-axis you can take any input for this. But the thing is, it will take only the positive domain. It will map only the positive because it is x square and it is a positive. So it will take only the positive domain, that is 0 to infinity. Okay, it will take from here 0 to infinity. It is what 0 and it is infinity. It will take 0 to infinity of f of x. Notice that one thing is, it is an even function. It is what even function. Okay, even function. So this is all about this function. And another thing is that it is a non-monotonic function. Okay, it is non-monotonic. Okay, non-monotonic, right? Function. Non-monotonic function means that from here it is decreasing with increasing the value, and from here it is increasing with increasing the value. Okay, so it is non-monotonic, decreasing and increasing. Okay, and for convex and concavity, it is a convex function. Okay, here it is minima is lies here, so it is a convex function also. It is what convex function we can also say. Next we have function x cube. X cube is a function like this. Okay, this is the graph of function, and the domain, it will take whole real number. Okay, the domain will take whole real number, and the range also it will take, it will give whole real number. Okay, but the thing is, it is an odd function. It is odd function, and also it is increasing function. With increasing the value, it is increasing, and here it is also increasing. So it is increasing function. Okay, monotonically increasing function we can say also. Okay, next we have this function, and it is a generalized case here, which is something x. Okay, which is something f of x, x power 2n, where I will put n is equals to 0, then it is a constant function, then it is f of x is equals to 1. Now you can see it is what 1 here. Okay, but if I will put n is equals to 1, then it is x square, means it is what? It is a parabola, or it is a x square. And when I will put n is equals to 2, then it is x power 4. You can see it is my x square. Okay, it is my x power whenever I will put n is equals to 0. And here it is what n is equals to, I will say it is my n is equals to 1 here. Okay, sorry. Wait a second. It will 1. Yeah, n is equals to 1 will be 2. Yeah, it is n is equals to 1, and it is what? N is equals to 2. You can see by increasing the value of n, it will get narrow. Okay, it will get narrow from here to. Okay, this is the thing important in case is here. Or if I will take, okay, this is what? This is the function x square. This is the function x power 4. If I will take n is equals to 3, then it will be 6. Then of course, then it will be like this. Okay, it will also like this. Then this is the case, it is getting narrow. It is getting, okay, this you can say this amplification is getting decrease. Okay, this is the thing. But what is the domain for this? Domain we can take from real number. Of course, it is a x, and range it will take only the positive from 0 to infinity. Okay, from 0 to infinity. Here I have made a mistake. It will open. Sorry for that. Okay, from 0 to infinity. And notice that it is a even function, of course. If it is a 2 power n, then it is a even function and non-monotonic function. Okay, next we have odd. The same case arises here, but the thing is, if I will take n is equals to 0, then it will be x power 1. It means it is a straight line. This is what n is equals to 0. Again, this is what n is equals to 1, and this is what n is equals to 2. So you can see, by increasing the value of n, it is tending toward the f of x. It is tending toward the value of this, and it is getting narrowed down. Okay, here it is like this, and here it is like this. Okay, so what is n is equals to 3 here? N is equals to 3 will be something like this. Okay, this is n is equals to 3 here. So these are the functions. So what is the domain here? Domain is real number, and range is also real number for this, and it is a odd function. Okay, if it is odd power. Next, we have something. How can we identify, or how can we draw this kind of function, which is something we can say x power 2n plus 1 minus x. In this case, okay, no need of finding the domain and range here. We are just getting that what is the cardinality of this kind of set. If I will take x power 2n plus 1 minus x is equals to 0, or it is a set we are taking, okay, is equals to 0, and it means if I will define my a such that x power 2n plus 1 minus x is equals to 0, then what is the cardinality of this set? How can we identify? This is just a simple. What is this? If I will take n is equals to 1, then it is what? This one, this green, oh sorry, this green one. This is for n is equals to 1. And after that, it is what x is equals to, and it is what minus of x. Then it is cutting by minus of x. Then it will like this. It will pass through origin. Then this will be like this. Now you can see on how many point it is cutting to the green line. It is 1, and here it is intersecting, it is 2, and it is 3. So on 3 point, the both are intersecting. It means it is what? X of q is equals to x. Okay, this is the thing. So the cardinality of this is getting 3. This is the one of trick that you can find the cardinality of these kind of set. So for example, this is what? It is x power 50. X power 50 means x power 2n, where you have taken n is equals to 25, and it is what? X plus 1, and it is a line. It is what? A line. So for here, what is this? It is a x power 52n. We have seen that what is the graph of here? It is like this. Wait, it will be like this. Okay, it is x power 50, and now it is what? X power x plus 1. So it is x plus 1 is equals to 0, means x will pass through minus of x will pass through minus of 1. Then here, then it is like this. So how many point it is intersecting to this? This is one of the point, and this is second point. So the cardinality of this is getting 2. So this is cut on curve. So this is the thing that you can find the cardinality of this kind of set. Okay, so this is all about a simple function, and next we move to the rational function. So what is the rational function here? Rational function is something like this, 1 by x, okay, in which x here. The thing is that what is the maximum value for this? If I will put like this, limit x tending to positive infinity, then it is what? Positive infinity. Similarly, limit x tending to negative infinity, then it is what? Minus of infinity. Okay, sorry, 0, positive 0 and minus of 0, sorry for that, positive 0 and negative 0. So from here to positive side of 0, it is what? Plus infinity, and from here it is what? Minus infinity. If I will take these all values, then it is going to 0. So for positive 0, so from here, so 0. So for positive 0, it will go to positive infinity. For negative 0, it will go to negative infinity. The same thing is here. It is called like hyperbolic kind of function. It is here, and it is what? Strictly monotonically decreasing. It is what? Strictly monotonic. But here, wait, strictly monotonically. Okay, it is what? Strictly monotonically. Whatever the value is going, it is getting decreasing, and here it is also getting decreasing. So this is what the case here, and the domain of this is what? R minus of 0. It means you can't take 0 here. Okay, if you will take 0, then it will go to infinity, and the range is also, it will take it will never will take 0. So this is the thing, and you can also write like this, r by 0, or it is also r by 0. Okay, so this is the case here, and it is a negative function. If you will take f of minus x, it is odd function, not negative function, it is a odd function. Okay, how it is odd? If you will take minus of minus x, then it will be minus 1 by x, which is nothing but minus f of x. Now similarly, if you will take my 1 upon x square, then what is this? It will take whole. Okay, this is, it will take r over r by 0. But what is the range for this? It is taking the whole r, which is positive here. But the thing is that it is always be positive, but not, okay, but not 0. R plus, and like this is the, you can take this is the thing here, and it is even function. Okay, if you will take f of minus x, then it is nothing but 1 upon minus whole square, then it is nothing but 1 upon x square, which is your function of x. So this is the even function. Again, if you will take like this, the domain will depend on the value of n. Like this is just a visualization how it will getting here it is what the green line. Okay, yeah, if I will take n is equals to 0, then this is nothing but a simple line which is showing by the red line. If it is n is equals to, if I will take n is equals to 1, then it is showing by green line, then it is here. Now here in this case, if I will increase n, it is it is moving out, like moving opposite to the like function value. In that case, we have like this x power 2n, then in that case it is moving toward this. Now it is not moving toward this, it is going opposite to this, it is going far from this f of x. Okay, then again if I will take higher the value, then it will like this. So this is the thing, or because of that, that's the like reciprocal of this x square is moving toward this function, this f of x, but here 1 upon x of f of x is going like far from this f of x. Okay, this is the thing, and this is also the odd case here. Okay, whatever we have seen in that x power 2n plus, you can take plus 1 also here, you can take plus 1. So it is also but it is not plus 1, yeah, it is minus 1, that you can take also the thing. So it's basically it is also the reciprocal, it is giving this kind of curve here. Okay, this is a odd kind of function which you can say. Next we have a rational function, irrational function. Like these all are rational function. Next we will see these are the rational function, then irrational function. So irrational function is like something x root of x. Root of x will take only the positive value, only positive value with 0. Okay, so the domain will be the positive with 0. It can also take 0, at 0 it will be 0. So it is a comparison with x of x square. This is x square and this is root of x here. Okay, so this is the case here arising here. Okay, here from if you will take x is equals to 0, then it will intersect, all of three curve will intersect at a point. Okay, this is the property of this curve. And again, what is the range of this like this the function? Wait a second. Domain we can take anything. Domain we can take 0 to infinite, not negative. Okay, or range will be like this, positive r. Okay, positive r union 0. I think this is the same thing. No issues here. So y is equals to root of x. You can say y square of x. It means it is what? It is nothing but a parabola symmetric to x-axis. Here it was y is equals to x-axis, and it was this symmetric to y-axis. Now if it is y square x, then it is a parabola, but it is a positive kind of parabola. You can't take negative value here. Okay, next it is what? 1 by root 3. The same thing is here. You can take, okay, you can take any value, and you can find out. This is for you can find out the domain and the codomain for this. Okay, next we have piecewise function. These are very important function. We'll discuss this. So what is this? Mod function, or we can say modulus function is also there. That's absolute function, we can also say. It will be always positive. So whatever this, it can be defined like this. F of x is nothing but minus of x for all x less than 0. and x for all x greater than, okay, here it can be like this, or it will be 0 for x, it will be x greater than 0, okay, or it will be 0, you can put equal to any equal to anywhere, okay. Now in this case it is what line which is passing through origin but not taking the negative values here, but not taking input as a negative like this. If you will take there, so the domain is whole R, you can take domain as whole R, but it will give only the positive value from where 0 to but it will give from 0 to infinity here, okay, 0, this one is 0 and this one is infinity, this is y, okay, this is the case. And it is a what, it is a even function. Because of that, if you will put f of minus x, then mod of minus x is nothing but x, okay. These are the function which is what, this one is something, if it is shifting toward 1, okay, shifting toward right, and this is what shifting toward left, then here it is what, x is equals to 1 means x minus 1 is equals to 0, and here it is what, x minus 1 is equals to 0 means x is equals to, wait, x is equals to minus 1, sorry, x is equals to minus 1, then x plus 1 is equals to 0. So this is what mod of x minus 1, and this is what mod of x plus 1. So these are the shifting on x-axis. You can take as shift any constant here. Okay. Next one is signum function. What is signum function here? Signum function is defined like this. Okay, signum function is defined like this: x upon mod of x, or you can take mod of x upon x if x is not equals to 0. It means that if you will take this, then this will what, x upon x, it will be 1 if x greater than 0. It will be 0 if x is equals to 0. It will be minus 1. X upon minus 1 is what, when x is less than 0. This is the signum function as defined, and it will take whole domain, but it will give 3 value. The range set is 0, minus 1 and plus 1. So these are the value. You can see for any value it is what the constant, it is taking only 1. For any value it is what the constant, and for 0 it is 0. This is called the signum function. Okay, this is the important potential of this, and it is a piecewise function. Next we have shifting of signum function. If I will take x minus 1, signum of x minus 1, then you can see it is what, it is here, it is 1. So it is shifting left side, sorry, right side, shifting right side, and it is what, shifting left side. You can see here it is 1 and it is shifting with 1 point. Now next we have greatest integer, which is also known as floor function. Greatest integer is something, if you will take 3.01 of greatest integer, then it is 3, it can be denoted like this and like this. Okay, this is a floor function we can also say, and it is a greatest integer function. Okay, for example it will 2.9, then it is 2. For example 0.9, it will be 0. So it means that from here, if I will see, this one is for 0 to this, here it is what, you can feel whatever the value in between 0 and less than 1, in between 0 and less than 1, it will be 0, like 0.99999, and greatest integer of this is 0, it is not 1. For 1 to 2, it will be 1. Okay, for 2 to 3, it will be 2. So this is the definition of this. And one thing is that for minus 1 x 0, what is the greatest integer here? Which one is greatest one? So it will be minus 1. Okay, it will be minus 1 here. So these are the definition. You can see here we have plot like this. It will be 0 up to 1, but for 1 it is taking this value. Okay, again it is 1, it is 2. If it is 2, it is not taking 2 here, it is not taking 1 here, it will go up to 2. In between this will be 1, in between this. So this circle, empty circle, is showing that it is not taking the value here, it is taking the value here. So this is what the graph of this plot of this. Okay, now here range, it is what you can see, the domain is whole real number, but it is taking only the integer value. Okay, only the integer value, and it is what monotonically increasing function. Okay, this is monotonically increasing function. This is the property of this. Next we have least integer. This is just the opposite of that. How is it opposite? Least function means that, okay, one thing is that we have some note point here. Whatever the greatest function of x, it is x if x belongs to integer. X integer. These are the some property I want to mention here. Okay, in note point we can write here. So first one is greatest integer of x is x if x belonging from z. Okay, so if it is x plus I, then it is nothing. I means integer also. I means integer. So it will be greatest integer of this plus I, where I belonging from integer. It means, for example, 7 plus, you can see 9 plus 5. So we can write like this. It is what? 0.5 is not integer, plus 9, it is integer. So it is nothing but 0.5 plus 9. So whatever it is nothing but 0. 0 plus 9. So the greatest integer will be 9 for this. Okay, this is the case here. Property. Next we have like this. If you have greatest integer of x plus y, then it will be greater than of greatest integer of x and greatest integer of y. Of course, it will take least one. Okay, greatest integer of minus x is nothing but minus of greatest integer of x and greatest integer of you can say minus of x. Okay, it is for what? X is belonging from integer, and greatest integer of minus x, it will be x minus 1 if x belonging does not belongs to the integer. It means minus of 7 is nothing but minus 7, and it is nothing but minus of 7. But if it is minus of 7.1, it is not integer. Now it is what? It is minus, it is what? 7.1 minus 1, it is 6.1, and the greatest integer of 6.1 is nothing but 6. So it is what? 6 here. So this is the case here. You can see how the greatest integer is working. Next we have least integer function, which is called ceiling function. So it is taking the highest value of this. It means that if first I will define like this, if the values in this equals to 1, then it will be 1. So 0 to 1, it will be 1. Okay, then it is what? 1 to 2, it will be 2. It is taking upper value. So it is 2 to 3, then it is taking 3. Okay, this is what. So if it is minus 1, okay, if it is from minus 1 to 0, 0 is including, then it is 0, taking upper value. So the domain is what? Domain is real number, but taking the range of function, it is taking only the integers. Now how? If it is 0, if like it is minus 1 to 0, it is taking minus 1 to 0, it is taking 0. Okay, minus 1 to 1, it is taking 0, not this, it is empty. From here it is taking this, it is empty. From here it is taking this, it is empty. So you can see these both graph are opposite. Here it is what? Here it was filled. Yeah, it was filled. But you can see from here, it is starting like this. Now it is starting like this. It will be 0. It is 0 only for 0. It will never be 0. It will never be 0 for positive thing. But here it is negative. It will be 0 for negative. For example, minus 0.7, it is 0. Okay, if it is floor function, if I will take ceiling function 0.7, then it is what? Minus 1, because this one is the greatest integer for this. Okay, this is the case. You can understand the thing. Next we have, it is monotonically increasing function. Again, it is what? Monotonically increasing function. Okay. Next we have fractional part function. This one is important. What is the fractional part? It is defined as x minus greatest integer of x. X minus greatest integer of x. Domain is R, but range is only 0 and 1. It is in between 0 and 1. Okay. whenever it is going to 1, it will again come to 0. It means that it is defined like this: x for only 0 to 1. It is x minus 1 for only 1 to 2. X minus 2 for 2 to 3. So for that, if you will take, wait, it is not list integer function. Okay, wait a second. Yeah, it is taking like this. It is what? Here, again it will be here. Here, 1, okay, until it will be 1, until unless it will be increasing, it will like reaches to 1. If it will reach to 1, it will come to 0 again. It will come to 0. Here it will, if it will reach to minus 1, it will be 0. Okay, this is the property of this function. Okay, next we have logarithmic and exponential function. These are the function logarithmic and exponential function. If we'll take any constant power x, then it is like this. If my a is greater than 1, then you can see it is moving toward the function. Okay, it is what? A is equals to 2. If it will, if a should be greater than 1. Okay, a should not 1. If it is 1, then it is only 1. A should be greater than of 1. Then it is what? 2. It is 3. It is 4. Okay, it is a is equals to 2. A is equals to 3. A is equals to 4. It is 2, like moving toward this. But the thing is that it is not getting infinity. It is not getting 0. It will be minus of infinity. Here it will be plus of infinity. The same thing is here. Okay, if it is in between 0 and 1. Now, next one is log. This one is log when a is greater than 1, and this one is log when a is in between 0 and 1. This is the case. The one thing is that if we'll take a is equals to 2.73, it means it is called e. Then it is like this. And if it is e to the power minus of x, then it is not 0. It is, you can see it is minus. It is for this, it is 5.23 into 10 to the power minus 2. It is not getting 0. It will be minus of infinity and it will be plus of infinity. It is asymptotic. This property is called asymptotic. Now, sine hyperbolic of x. Sine hyperbolic of x is something which is related to exponential. That's the same case here. It means sine hyperbolic is defined as e to the power of x minus e to the power of minus x by 2, and cos hyperbolic of x e to the power of x e to the power of minus x by 2. You can see this is what? E to the power of x. Okay, e to the power of x like this. Okay, same. E to the power of minus x like this, but it is what? E to the power of minus. So the negative part of this. So this one is like this. So the intersection and divide by 2 is also there. So it will be this. Okay, this one is minus e to the power minus x, and this one is e to the power of x. Similarly, this is what? E to the power of minus x, and this is what? E to the power of x. So it has like the value like this. You can see, you can compare with this. Okay, next we have tan hyperbolic x. What is the tan hyperbolic? Tan hyperbolic x is sine hyperbolic x upon cos hyperbolic x, which is nothing but e to the power x minus e to the power minus x upon e to the power x plus e to the power minus x. And it is what? The reciprocal of tan, e to the power of x plus e to the power minus x, and e to the power of x minus e to the power minus x. These are the graphs for that. And after that, we have some well-known functions are there. That is trigonometric function. Okay, trigonometric function, we will just define what is the properties and all. So first of all, what is the domain? I will define like this. What is the domain of function? If it is f of x, then domain of function for sine it is r. But the range of that function, it is taking minus 1 and 1 only. You can see it is bounded in between minus 1 and, okay, it is 1 and it is minus 1. For the same thing is for cos. Okay, and what is the period? So for this is period is 2 pi. After, you can see it is 2 pi. It will again going to repeat it. Okay, so this is the 2 pi. So what is sine of x? Sine of x for all x is it? Sine of x is equals to 1. For all x is equals to 4n plus 1 pi by 2. It means even. And similarly for sine of x taking minus 1, for all x is equals to 4n plus 3 pi by 2 for all odd values. Okay, where n is 1, 2 and all. Next, we have the function cos of x. Domain is real number. and the range is -1 to 1. For here, the period is 2 pi. This is t. T stands for period. Okay, T stands for period. Now it is what? Even. It is odd function. Okay, it is odd function. Cos is even function. Cos is even function, and here it is cos of x is taking 0. One thing is that, yeah, sine 0 is for sine of x is 0 for x is equals to n pi by 2. Okay, wait, no, it is pi by 2. Sorry for that. Pi only n pi, no, not n pi by 2. Okay, yeah, only n pi. Then it is cos, yeah, cos is taking 0 for n pi by 2. Cos is taking 1 for odd values or for 0. Okay, yeah, it will be 4n plus 1 pi by 2. Yes, and cos is taking -1 for all 4n plus 3 pi by 2. Okay, these are the values here, which is specified. Next one is, if my f of x is as tan of x, then the domain of this, you can see, domain is what? Whole real number, but there are some points, whole real number other than 2 pi, other than we can say this, these are the thing here, it will go to infinity from here to here. So 2 pi plus, wait, 2n, wait, n pi, no? Other than 2n plus 1 pi, yeah, it is 2n plus 1 pi by 2. If for 10 pi by 2, it will be infinity. Okay, and the range is again taking real number. Period is pi, it will repeat after pi. Okay, this is what 3.14, and it is something pi, again it is pi 3.14, you can see here. Okay, next we have cot of x. Domain for this is real number but not n pi. It is for n pi, it is going to infinity. Okay, for 0, you can see 0, n pi, n is equals to, if we'll take 0 and pi, it is also going to infinity. For this, it is pi and it is going to infinity, minus of infinity. Okay, you can see here range of this function, it is real number, and period is for this also, and this is odd function. Okay, this is odd function, and tan is also odd function here. Next, sec of x. Sec x is something 1 upon sine x. Okay, this is 1 upon sine x. Sorry, 1 upon cos x. 1 upon cos x. So here domain is r minus 2n plus 1 pi by 2. Okay, but the range is something, range is here whole real number other than -1 and 1. Okay, it is an even function because cos is even, then it is also even function. This is cosec. If my f of x is equals to cosec x, then domain of this function is r other than n pi. R other than n pi. And next one is here, it is range of f r other than -1 and 1. Okay, and it is also odd function. For these both, period is 2 pi. Okay, these are the cases. Next, we have trigonometric function. These are inverse trigonometric function, which is something sine inverse of x, which is something cos inverse of x. Okay, next we have tan inverse of x. This is the plot of tan inverse of x. This is the cot inverse of x. Next, it is for sec inverse of x. Okay, this is sec inverse of x. Okay, sorry, cosec inverse of x. This is cosec inverse of x, and this is sec inverse of x. Therefore, x is here. Okay. So next one is mod. You can see what is mod of x, taking positive value, but mod is taking now in case in the pattern of sine of x, it is taking only the positive value. Similarly for cos. And if I will make like this, this is for different value of a of sine ax. If it is what sine ax, if I have taken like this sine of ax, then it will be like this. Okay, sine ax, a sine x. Okay, sine x by a, then sine a power x and sine x power a. These all are the different graphs for that. Next, we have some composite function. What is the composite function here? We'll start with e to the power x. It is e to the power x. Okay. If I will take e to the power mod x, then it will take only the positive. Mod is like this. See, mod is like this. But here it is what? It will take the shape of e here and here, like positive e. E to the power mod x means what? E to the power minus x, e to the power x for x less than 0, for x greater than 0, and it will be 1 for x is equals to 0. So you can see here it is 1. It is not here, it is 0. No, it will not be 0. It will be 1 here. Okay, it is range is you can't say. If you will magnify this, then you can get it is what fractional part function. Then this is again this. If you will take sine mod x, okay, this is positive sine mod x, not mod sine x. Mod sine x is something taking positive value only. It is what sine mod x. Sine mod x something like this. Okay, this is m and this stands for MS Maths. Next, it is sine of x. Okay, this is sine of x. Then it is sine of x and like this. If we'll take sine of fractional part, this is what the fractional. So here it is what fractional. Next one is sine of a fractional part of x square, and this is x square, and the fractional part of x square. It is fractional part of sine x. It is sine, sorry, e to the power x and fractional part. You can see here it is what the integer function, greatest integer like this, but not taking negative value because it is a square. So you can see it is taking the shape of x square, but with with integer. Here it is also, if you will take like this, then it is also taking the integer part here, and it is all like taking here e to the power of greatest integer here. Okay, so these all are the value here, and this is related to all about the graphs of function. So here it is. I have discussed all the things related to the important function, their graph and domain. So thank you for watching. Thank you. Bye bye.